Theoretical recap. DNS, Domain Name System, is the Internet's phone book. It translates human-readable hostnames, for example, example.com, into IP addresses that routers and hosts can use. A DNS lookup follows a strict hierarchical resolution chain. Your machine first checks its local cache, then queries a recursive resolver, usually provided by your ISP or configured manually, for example, 8.8.8.8, which in turn contacts root servers, TLD servers, and finally the authoritative name server for the domain. The result is cached according to the TTL, time to live, value attached to each DNS record. Key record types to know: A. IPv4 address, AAAA, IPv6 address, CNAME, alias, MX, mail exchange, NS, name server, PTR, reverse lookup, text, arbitrary text, used for SPF/DKIM. DNS operates over UDP port 53 by default, TCP for large responses or zone transfers. Common mistakes: confusing the recursive resolver with the authoritative name server, forgetting that cached results may be stale, ignoring that DNS is unencrypted by default, hence interceptable. From a security standpoint, DNS is a prime target for reconnaissance, cache poisoning, and data exfiltration via DNS tunneling. Mini example: running dig google.com returns the A record with its TTL. Running the same command twice in quick succession shows the TTL decreasing, confirming local caching behavior. Workshop brief. This workshop puts into practice the DNS concepts introduced in the previous chapter. You will manually trigger DNS lookups, observe the full resolution chain at the packet level using a network sniffer, interpret the captured frames, and then deliberately break DNS resolution to diagnose and fix the problem. This sequence mirrors real-world tasks performed by both sysadmins and security analysts during network troubleshooting or reconnaissance phases. You have 3 days, approximately 4 to 5 hours of focused work, to complete this workshop and submit your solution before the deadline expires. Step 1. Environment Setup. Work inside your Linux VM, the same environment used in previous routing and NAT workshops. Verify that you have the following tools available: dig, nslookup, host, TCP dump or Wireshark, or both, and iptables. If any tool is missing, install it using your package manager. Confirm that your VM has working internet access and note the DNS resolver currently configured in /etc/resolve.conference. Take a screenshot or note of this baseline configuration, you will need it later. Step 2. Observe a normal DNS lookup. Before capturing anything, use dig to resolve at least 3 different domain names. Choose domains with different TLDs. Note the answer section, the query time, the server used, and the TTL for each record. Run each query twice and explain in your notes what changes between the first and the second call, and why. Now, launch a packet capture, TP dump or Wireshark, filtering on UDP/TCP port 53, then trigger a fresh DNS query for a domain whose TTL has expired. You can force this by flushing the local DNS cache if your system uses systemd resolved or NSCD. Save the capture file. In your analysis, identify and annotate the DNS query frame, client resolver, the DNS response frame, resolver client, the transaction ID, the queried record type, and the TTL in the response. Step 3. Trace the full resolution chain. Using dig with the +trace flag, perform a full iterative resolution for a domain of your choice, starting from the root servers. Document each step of the chain: root server contacted, TLD server contacted, authoritative name server contacted, and final answer. Capture this traffic with TP dump simultaneously. In your submission, provide the full dig +trace output and map each resolution step to the corresponding packets in your capture. Explain in plain language what each intermediate server's role is and why the chain works this way. Step 4. Break and fix DNS resolution. Now deliberately break DNS resolution on your VM using at least 2 different methods. Suggested approaches: modify /etc/resolve.conference to point to a non-existent or unreachable resolver. Use iptables to block outgoing traffic on port 53. Introduce a wrong entry in /etc/hosts for a domain you will query. For each method, document the exact change you made, show the error or unexpected behavior you observe, with tool output or packet capture evidence, diagnose the root cause, and restore the correct configuration. This step assesses your ability to apply diagnostic reasoning, the same skill used during PenTest reconnaissance when DNS anomalies reveal misconfigured or filtered environments. Step 5. Security perspective. Sniffing and analyzing DNS traffic. Capture at least 30 seconds of DNS traffic while browsing normally or running a script that resolves multiple hostnames in sequence. Open the capture in Wireshark. If you use TCP dump, import the PKP file. Apply display filters to isolate DNS traffic. From this capture, answer the following questions in your written report. Which domains were queried? Are any queries repeated? And what does that tell you about caching? Is any DNS traffic going to unexpected resolvers, not the one in /etc/resolve.conference? What would an attacker learn about a target system by passively sniffing its DNS traffic for 10 minutes? This last question requires a short analytical paragraph, minimum 80 words, that connects your observations to real-world security implications. Submission requirements. Your submission must include 1. A written report in PDF or Markdown format covering all 5 steps with annotated screenshots or terminal output. 2. At least 2 PKP capture files, 1 from Step 2, 1 from Step 5. 3. Your analytical paragraph on the security implications of DNS sniffing. Be precise and concise. Your report should demonstrate both technical understanding and the ability to reason about what you observe. You are allowed and encouraged to consult the previous course chapters, DNS theory, routing tables, NAT, firewall concepts, and any relevant internet resources. You may work alone or ask for help, but the written analysis must reflect your own understanding.